my project is FPGA based Monte Carlo simulations for black Scholes pricing error. So in this presentation we have this content. First is overview of FPGA and Monte Carlo simulations. So what is definition of FPGA and what are the features of it? So it provides us parallel computing and offers flexibility and reconfigurability of the specific application. And why are we applying FPGA board in this financial application? Because we need high speed data for processing and reducing latency and effective parallel computing to make the calculations faster. Now what like Monte Carlo runs are like foundations for any statistical methods where we redo things again and again so that we get a better estimation and decision making. What are the applications of this model in option pricing is we are using this black Scholes model to predict if the market is currently underpriced or overpriced. Now what is black Scholes option pricing from? Now what is the BS model? So I'll use this presentation over here this is a website and to explain the BS model. So BS model is like a mathematical equation used to calculate fair price. What will be the fair price of a model? So it was developed in 1973 and it is widely used in current financial market. Now let's come to mathematics part. So we have this equation of the model and we can get all these parameters of current market data for current market price, and then we have like C is call option price and S is current stock price which we have from the data, K is a strike price, we also have this data, and R is risk free interest rate, we also have this data, and T is obviously we define the T, and N is like normal distribution of this D2. So we apply this formula again and again using Monte Carlo simulations, and then we get some results. So here are some benefits and limitations of the model, because we require a stable and like ideal market. In the real market the outputs are different from the given results. Now let us come to the code part. So I have coded it in Verilog code for Edge Z20 or Edge Xilinx Zinc board, and these are few files which show you these are like mathematical operations which are used in the formula. So I have coded them separately, and then we have this top file. Here we are defining the top module, and we have like button counter and previous and start pulse. So here we define the pricer model, or we initiate it, and initiation is done here, and this is our pricer model where we are initiating the black Scholes model. So pricer model what this does is it gives the current price of the market data right now. This is the black Scholes model definition, and we have defined the parameters which are used. This is our Monte Carlo simulations. So we are using both of these to get the output of the data, and this function is used to create random values which are used in Monte Carlo method, and this is used for Gaussian noise. Now let us synthesize the code. Now the synthesis is complete without any errors. Let us run the implementation. Now the implementation is done. Let us generate the bit stream. We have generated the bit stream. Let us see the implementation. This is the circuit implemented on the board. So this is the hardware implemented. So yeah, that is it. These are the codes I will share on GitHub, and this is the complete project. So we have this UART file, which what it does is the FPGA board is connected to the PC or the system, this system. So I will show you where. In the ports we have this FPGA boards connected as COM8. So what it is doing is currently it is so what that file does is it shares what the output generated on the board to the PC. How it shares is we have this software putty. Here we have defined in this top here I have defined the UART transmission. So what it is doing is it is transmitting at this bit rate. So we are going to put this in serial mode, and then we had that port as COM8, and the speed at which is defined as 115,200 bits per second. Open, and here we are going to receive the output generated. So let us go to hardware manager and program device, and we program it, and the putty was disconnected because this Vivado software was using the serial port. So again we have to connect it. COM8, here we are supposed to get the output, but now I am not able to transfer the output correctly to this board. The calculations are done, and this was my process in the progress of the project. Thank you.